Good morning, students. Today we are starting with three-dimensional geometry. P is any point in the space. You can say OA is equal to small a, OB is equal to small b, and OC is equal to small c. Then coordinates of P are capital P, A, comma B, comma C. Angle POX is alpha, angle POY is beta, angle POZ is gamma. The direction ratios DCs are small a, small b, small c. The direction cosines DCs are LMN. L is cos alpha, M is cos beta, N is cos gamma. L is cos alpha, A upon under root A square plus B square plus C square. M is cos beta, B upon under root A square plus B square plus C square. N is cos gamma, N is C upon under root A square plus B square plus C square. If we square them and add, you will find that the sum of their squares is 1. Exercise 11.1, we are given the value of alpha, beta, gamma. We find the value of LMN. L is cos alpha, cos 90, 0. M is cos 135, can be written as cos 180 minus 45, second quadrant cos negative, minus cos 45 minus 1 by root 2. N is cos gamma cos 45 degrees, that is equal to 1 by root 2. The DCs are LMN 0 minus 1 by root 2, 1 by root 2. Find the DCs of a line which makes equal angles with axis. L, M, N are equal, but we know that L square plus M square plus N square is 1. So L square plus L square plus L square is 1. 3L square is 1. L square is 1 upon 3 and L is equal to M is equal to N is equal to plus minus 1 upon root 3. If DRs are given A minus 18, B 12, C minus 4, we find out LMN. L is minus 18 upon 18 square, 12 square, 4 square. 18 square is 324, 12 square is 144, 4 square is 16. The total is 484, under root 484 is 22. So L is minus 18 upon 22, M is 12 upon 22, N is minus 4 upon 22. LMN on simplification we get minus 9 upon 11, 6 upon 11, minus 2 upon 11. Next topic is straight lines. Equation of a line passing a point parallel to a line. Vector form. Passing through a point A and parallel to a vector B, R is equal to vector A plus lambda vector B. Cartesian form. Passing through the points X, Y, Z, X1, Y1, Z1 and parallel to a line having DRs A, B, C. X minus x1 upon a equals y minus y1 upon b equals z minus z1 upon c. Equation of line passing through 2 points is vector form. Passing through points a vector a and vector b. Note vector b is over here a point. In the previous one it was a parallel vector. R vector is equal to vector a plus lambda b minus vector b minus vector a. Cartesian form passing through the points x1, y1, z1, x2, y2, z2 is x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. On the basis of this formula, let us do two questions. Find the equation of a line passing through the point 1, 2, 3 and parallel to the vector 3i plus 2j minus 2k. A is I plus 2j plus 3k. B we consider 3i plus 2j minus 2k. We are expressing the points in vector form. Y for vector representation. R is equal to vector A plus lambda vector B, that is equal to I plus 2j plus 3k plus lambda 3i plus 2j minus 2k. Cartesian form, x1 is 1, y1 is 2, z1 is 3, a is 3, b is 2, c is minus 2. We get the Cartesian form x minus x1 upon 3, y minus y minus y1 upon b, z minus z1 upon c as x minus 1 upon 3, y minus 2 upon 2, z minus 3 upon minus 2. Find the equation of a line passing through 2i minus j plus 4k and 3i plus 4j plus 5k. R is equal to a plus lambda b minus a. A is 2i minus j plus 4k plus lambda. From b we subtract a, we get R is equal to 2i minus j plus 4k plus lambda I plus 5j plus k. Now the points are x1 y1 z1 2 minus 1 4, x2 y2 z2 3 4 5. In Cartesian form it is x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. We equate the values of x1 y1 z1, x2 y2 z2 and get the answer x minus 2 upon 1, y plus 1 upon 5, z minus 4 upon 1. Shortest distance between the lines. If there are two lines, r is equal to a1 plus lambda b1, r is equal to a2 plus lambda b2. In place of lambda we can take mu also, two different constants. Then the distance between the two lines is given by b1 cross b2 dot a2 minus a1 upon magnitude of b1 cross b2 and modulus of this. Cartesian form is, if lines are given, x minus x1 upon a1 equals y minus y1 upon b1 is equal to z minus z1 upon c1, and line 2 x minus x2 upon a2, y minus y2 upon b2, z minus z2 upon c2. Then the distance is given by determinant x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 divided by square root of a1 b2 minus a2 b1 square, b1 c2 minus b2 c1 square, c1 a2 minus c2 a1 square, all under modulus. Distance we always consider as positive. That is why we keep the distance in modulus. If the answer is negative, still we give the positive answer. Let us consider two questions based on these formulas. Find the shortest distance between the lines I plus 2j plus k plus lambda I minus j plus k, 2i minus j minus k plus mu, 2i plus j plus 2k. A1 is given, A2 is given. Find out A2 minus A1, I minus 3j minus 2k. B1 is given, B2 is given. B1 and B2 are vectors with constants lambda and mu. A1 and A2 are vectors without which are single and without constant. So B1 cross B2 is the determinant ijk 1 minus 1 1 2 1 2. These are the coefficients of vectors b1 and b2. You can see I minus j plus k 1 minus 1 1, 2i plus j plus 2k 2 1 2. Let us solve the determinant. We get the answer minus 3i plus 3j. You know how to do the determinants, and the explanation is given over here also. The magnitude of this cross product, that is b1 cross b2, is written here. It is minus 3 square and plus 3 square. In square everything remains positive, we don't put sign. So 3 square plus 3 square is 3 under root 2. What is a2 minus a1 dot b1 cross b2? Let us find the dot product of a2 minus a1, that is I minus 3j minus 2k and minus 3i plus 3k. The dot product is 1, 1, 1 into minus 3 into 0, minus 2 into 3. This is minus 3, minus 6, minus 9. Now a2 minus a1 dot b1 cross b2 is minus 9. b1 cross b2 magnitude is 3 root 2. Let us divide and write the answer in modulus, that is positive answer. 9 upon 3 root 2 minus sign will become plus. 3 3s are 9. Multiply root 2 above and below. To rationalize the denominator, answer is shortest distance is 3 root 2 upon 2. Find the shortest distance between the lines given to us: x plus 1 upon 7, y plus 1 upon minus 6, z plus 1 upon 1, x minus 3 upon 1, y minus 5 upon minus 2, z minus 7 upon 1. Now one by one we are considering the lines. First of all, we recognize x1 is minus 1, y1 is minus 1, z1 is minus 1, a1 7, b1 minus 6, c1 1. Comparing x minus x1 upon a1, y minus y1 upon b1, z minus z1 upon c1 with the first equation. Then x2 is 3, y2 is 5, z2 is 7, a2 is 1, b2 minus 2 and c2 1. Comparing x minus x2 upon a2, y minus y2 upon b2, z minus z2 upon c2 with the second equation of the line. After finding out these quantities, first of all we find out x2 minus x1, y2 minus y1, z2 minus z1. They are coming as 4, 6 and 8. a1 b1 c1 is 7 minus 6 1. a2 b2 c2 is 1 minus 2 1. Put it in a determinant as shown. After solving the determinant, we get the solution of determinant as minus 116 under root a1 b2 minus a2 b1 whole square plus b1 c2 minus b2 c1 whole square plus c1 a2 minus c2 a1 whole square is minus 6 plus 2 whole square, 1 minus 7 whole square, minus 14 plus 6 whole square. It is also coming under root 116. Shortest distance is given by determinant upon under root. The value of determinant is minus 116. Value of under root portion is again under root 116. Minus sign will become plus. Now 116 can be written as under root 116 into under root 116. One of the under roots are cancelled out. We get the answer under root 116. Factorize 2 into 2 into under root 29. The shortest distance is coming 2 root 29. Find the coordinates of the point where the line joining A341 and B516 crosses YZ plane. Now some of the knowledge of the three-dimensional geometry you have studied in class 11 is used here. The 2-point form is x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. x1 y1 z1, x2 y2 z2 is given to us. The equation of the line in a general form can be written, put it equal to k. X becomes 2k plus 3, y becomes minus 3k plus 4, z becomes 5k plus 1. If the line crosses yz plane, then x coefficient and x coordinate is 0 on yz plane. So 2k plus 3 is kept put equal to 0. We get k minus 3 by 2. Put k minus 3 by 2 in y and z. We get the points 0, 17 by 2 and minus 13 by 2. Sixth question is write the Cartesian form of line x minus 5 upon 3, y plus 7 upon 4, z minus 6 upon 2 in vector form. How do we write it in vector form? Let us recognize x1, y1, z1 and ABC. The point is 5 minus 7, 6. This represent vector AI bj ck, that is 5i minus 7j plus 6k, and parallel vector will be 3i plus 4j plus 2k, and vector form is r is equal to a plus lambda b. In place of a, let us put 5i minus 7j plus 6k. In place of b, we put lambda multiplied by 3i plus 4j plus 2k. So students, you can finish the exercise 11.1 and 11.2. In the next term, we are going to start with plane, and this is all about three dimension geometry exercise 11.1 and 11.2. Please do it in your copies. Thank you very much.